So when you talk about the linear differential equation, generally the structure that you'll see is in the two different forms. Number one is your dy by dx plus a function of, like, here will be p of x, you can say a function of x times y equals to a function of x. Now this is the form that has been assessed 99% times in the exam. But there can be, if your differential equation is in terms of y, so it'll be dx upon dy plus p of y times x equals to q of y. So this can be also the other form, but generally the first form is assessed, and this is called as linear differential equation. Now, linear differential equation is basically sometimes in this exact form, and sometimes there will be a variable something here x. Like here you can see dy by dx plus 3x square y equals to 6x square is in a good structured form here. Like, okay, so if I compare dy by dx, p of x is this function, and q of x is the other side, and y is here. Now, if there was no y, this won't be a differential equation, linear differential equation then. So this has to be in this structure. So that's something which you got to remember. Now, our next step is to actually see what should be the strategy to solve this kind of question. So in this case, we use a very important strategy called integration factor method. Integration factor method. And obviously, this is to bring in the integral to something which is easier to integrate. So what exactly is integration factor? So integration factor is actually defined as e to the power integration of p of x. E to the power integration of p of x. So whatever is this function you see here, if you integrate that and raise to power e without the constant, because constants and all will be counted at the end once you finish the integration. But e to the power integration px dx is the call as integration factor. Now I'll tell the steps also, but before that there is some basic knowledge that you got to remember. E to the power ln x is x. So similarly, if you sometimes get e to the power ln of cos x, the answer is cos x. And it is important for here because sometimes you'll get the, if the integral is to the power e to the power ln, then you have to use this property for simplified integration factor. So once you get the integration factor, what is the next step? So now here for our problem here, the integration factor will be, so first let's identify p of x is 3x squared. So integration of this will be e to the power integration of 3x squared dx. You don't need to attach a constant when you integrate. So this will be nothing but e to the power of 3x squared integration will be 3x cube over 3. This and this get cancelled, so you take e to the power x cube. So this is the integration factor out here. And when you multiply both the side, this differential equation, by integration factor, you will see something very interesting. So let's see, when I multiply both the sides by e to the power x cube, see, when I multiply and simplify, this will be e to the power x cube times 6x squared. Now, when you do so, what you'll notice is that if I open this bracket, it is 3x squared y times e to the power x cube plus e to the power x cube times dy by dx equals to 6x squared e to the power x cube. And while you're doing so, what you notice is that actually there is a product rule here. And what what is this derivative for? So if you minutely observe, this is nothing but the derivative of y times e to the power x cube. If I see y times derivative of e to the power x cube, so y, if I just show it to you backwards, y times derivative of e to the power x cube will be e to the power x cube times 3x squared. So that's this part, plus product rule. So e to the power x cube times derivative of y, which is dy by dx. So you notice that this is the derivative of y times e to the power x cube. Now actually you don't need to think about it. You don't need to even think about it, like, while you're doing the next step out here. because it is gonna be, if you might do the integration factor correctly, it will be the derivative y times integration factor. This step that comes after you multiply with the integration factor, you do show the step, but you don't need to really analyze, okay, what is this derivative for? It is simply the derivative. You'll notice that this derivative will be y times the integration factor. Simple. If I go backwards, I'll get this. And this equals to 6x squared e to the power x cubed. So since we got now the derivative of y times x cube e to the power x cube is 6x squared e to the power x cube. Now we need to antiderivative this part because this is the derivative. So if I want to get rid of this derivative, it will be y e to the power x cube equals to integration of 6x squared e to the power x cube dx. Now this part you do by substitution. E to the power x squared e to the power x cube, you do by substitution here. So because in this left hand side the derivative integration cancel, but in this right hand side, let's take u as x cube. So du by dx will be 3x squared, and dx will be du over 3x squared. And so you put it out here, so it'll be 6x squared e to the power u du over 3x squared. So this get cancelled and 3 comes out. So it will be integration of 3 e to the power u, which is nothing but 3 e to the power u plus c. So at the end, this integral is actually y times e to the power x cube equals to 3 e to the power x cube plus c. So that's the integration of this part. And now what you do is you divide both the side by e to the power x cube. So you'll get y is 3 plus c over e to the power x cube, because if I divide this by e to the power x cube and isolate them, this get cancelled and you'll get this part, which can be further written as y is 3 plus c e to the power negative x cube. So this is the antiderivative, or this is the exact function that is expected for this problem. So this part, if you simplify, this is going to be 2 here outside. So this is 2 because 3 2s are 6. So you get 2 so 2 e to the power u, and 2 e to the power u integral is 2 e to the power u. And if you substitute back the original value, you get this as your final integration. Okay, so for this question, firstly, I identify the linear differential equation format. So dy by dx plus px times y equals to qx. So when you see here, p of x is nothing but negative tan x. So p of x is negative tan x. And q of x, you see, is nothing but cos x. So we define our integration factor. Integration factor is e to the power integration of px dx, which is e to the power integration of negative tan x dx. Now, once again, here negative tan x integral is tan x integral is a very important one, because it keep coming for as a surprise, because tan x integration, we don't have a formula straight away. If you can remember this method and then a final formula for tan x. So when you're integrating tan x, you obviously remember that this can be done by substitution, sin x over cos x. Sometimes IB expects you to show this calculation. So let u be cos x, and du by dx is negative sin x. And so yeah, so it'll become negative du by dx is this. So in place of dx, you can put a du over negative sin x. So you'll get sin x over u times du over negative sin x. Cancel, cancel. So you get negative 1 over du over u, which is negative ln u, which is negative ln of what do you say is cos x. And so let's put that value here. So it'll be e to the power of negative ln of cos x. So I would take the value of this will be negative and negative become positive, because there's one negative already here, And if you put this value as a negative, it will become positive. So cos x is your integration factor here. Now, since cos x is defined for all the values of x, so what we do is now after this, we multiply uh, both the sides by cos x. So cos x times dy by dx minus y tan x over, multiply by cos x equals to cos squared x. So when you do so, cos x times dy by dx minus y times, if you do sine over cos, it will become sine x equals to cos squared x. So now after this, blindly you can write down, this is nothing but the left hand side is derivative of y times cos x, y times integration factor. So equals to cos squared x. Now you integrate both the sides. So y cos x equals to integration of cos squared x dx. So sine squared x, cos squared x, you'll see that it comes in substitution, it comes in differential equation. So you need to have the solid base for this. And here we use the double angle formula. Cos 2x is 2 cos squared x minus 1. So if I make cos squared x a subject, it'll be 1 plus cos 2x over 2. So it'll be 1 plus cos 2x over 2. And if you integrate this, it is going to be x plus sine 2x over 2, and half is outside, and plus c. So y cos x equals to this. And of course, now I plug in x as pi and y is 0. So it'll be, this left hand side is 0 automatically. And half x is pi, and plus sine 2 pi is also going to become 0. So yeah, so constant is actually pi over 2 plus c. And so actual constant is c is negative pi over 2. So just put this value out here and you'll get the exact integration.